Andreas, how
Hello,
are you today?
I'm fine, thanks. How are you?
Not bad, thank you too. We are excited of the second day of Devoxx. What is the weather in Germany today?
Oh, it's sunny outside. It's cold, but it's sunny. So, quite nice.
You are lucky. Okay, what topic have you prepared for us?
I will talk about containers and Kubernetes and about security, especially for
Sounds
developers. So, not infrastructure part, but more the dev side.
sounds interesting. So, okay, the mic is yours. I'll come back in the end.
Okay, thank you. So, welcome to my talk, in my deep dive talk, containers and Kubernetes security for developers. My name is Andreas Falk, as already mentioned. I'm located in Germany, Stuttgart, in the south of Germany, actually. Uh, so I'm joining from there, from my home office, as you might recognize in these times. So you can reach me via email if you have questions after the talk, after the Zoom sessions for question and answer, or you can reach me via Twitter. I often tweet and also communicate over Twitter pretty much. Um, so my day job is pretty much consulting, developing customer enterprise software in mainly in Java in enterprise world using Spring framework and stuff like that. But my second part is about application security. So dealing with the whole application security world, like securing application, like authentication, authorization, defending against SQL injections, all that bad stuff that could happen. And as such, I'm also part of the Open Web Application Security Project as a member, and I'm also a member of the OpenID Foundation. Both communities are really keen on making the world a bit more secure. So the OWASP deals about web application security in general, and OpenID Foundation deals with a standard you might also know, like called the OpenID Connect standard, which builds upon OAuth. Today we will not have pretty much about OAuth and OpenID Connect, but more into container security. We also have some offerings. That would be the only advertisement slide for today. We also offer trainings and consultancy support in implementation and architecture, dealing with OR2 and OpenID Connect. So if you want to bring that into your project and need help, so just contact me. We also provide threat modeling trainings and workshops. So that's also the case. And we provide consultancy in general security questions, also concerning container security, Kubernetes, which is the topic of today. So the agenda for today, we have pretty much content for the 2 hours now. So I will start with typical use cases that we have nowadays when we use containers in our world. Then the second part would be a sneak preview. So what could possibly go wrong when you're dealing with containers? It could be quite dangerous if you're doing things pretty much wrong. And then the main part will be the third part, the path for secure development. So we'll have 4 stages that we'll look into. We will start at the application security. So it is not of further use if you push an insecure application into Kubernetes or into a container. So the container in Kubernetes does not make the application any more secure than before. So if you have a SQL injection in your application, then containers or Kubernetes will not defend against that. So because of that, we have the different stages to look for security. So we'll start with application security, and we'll be dealing with basics of container security. There we'll also have some basic Linux know-how that I will tell you, so how to understand containers, in fact. And then we're dealing with Kubernetes security, and the last part will be a bit of dealing with Kubernetes secrets. The slides and the code for that talk, that deep dive, is available on GitHub already. All the practical parts, the labs for that talk are also available already. So you can just download the slides already on that GitHub repository. As well as if you want to follow along the labs as I introduce them during that deep dive session, you just can follow along. So we have demos for all that iterations for application security with a simple application, with container security, and also for Kubernetes security. We won't have a demo, in fact, for the Kubernetes secrets part. I did not have time to prepare that, but we won't have time for all the demos. So in fact, for 2 hours are not that long. So we would need half a day if we also would require the secrets in practice. So what are typical container use cases? Why is Docker, Kubernetes, and all that stuff that prominent in our world nowadays? So it all started out by simplifying the development environments at first stage. So if you're a developer, you have to deal with lots of other components, like a database, like a messaging system, like an application container server, like Tomcat, for example, in that case. And it's often difficult to set up all these components by yourself on your local machine, like setting up a MySQL database or RabbitMQ is time consuming. So often you will use what is called Docker Compose, where you can just start up several Docker containers at once, one for RabbitMQ, one for MySQL, one for Tomcat, and then your development environment is ready, set up. You use your Eclipse IntelliJ IDEA, Visual Studio Code and stuff like that. Just develop your application, and you don't have to deal pretty much with that infrastructure part. So that's one use case that is very familiar, a very famous use case, a very well-known use case for the containers. So the second one builds upon the development environment, which is also used pretty much in our world. So like support for integration testing. So as well, if you want to do automated testing, lots of developers, for example, use H2 in-memory database instead of the production database to do database testing in that case. But that's doesn't simulate the real production environment. So I myself in projects had several problems with that approach because we tested against H2, but in fact, we have another SQL statements running on the production database, which then cause different problems that are not tested using the automated testing suite. And for that, we use testing containers that will be started behind the scenes when you run integration tests. So for example, if you want to run a MySQL or Oracle database, then this starts up in the back. You run your automated tests against that database, and after that it will be shut down again, and your automated test is finished. You can do that with several stuff. So we have lots of support for products like the typical databases all offer support for test containers. Also messaging systems. Pretty much I also test against identity providers like Keycloak that also provides a test container. So you can also test against a real identity management system. And you don't have to simulate your JSON web tokens and stuff like that. A well-known use case for sure is using Docker containers or containers in general in CI/CD pipelines. As you can see, lots of products that are available on the market build upon that container technology as integral part of their products, like Jenkins X or Concourse or CodeFresh. These are well-known products nowadays that have containers as integral part of their mechanisms. So for every build step, they just use Docker containers for isolated builds. So that makes it also very easy to build CI/CD pipelines nowadays. So these are all development and testing stages where containers originally have been used. Nowadays, with the rise of the Kubernetes product, we see more and more containers being pushed into production. And that's where security gets really serious nowadays. So if you just use it in development and testing, you might argue, we don't have to deal pretty much about security. That in that case, because nobody from the outside world should access our CI/CD system or should access our local development environment. But things are changing pretty much if you going into production with your containers, pushing them into Kubernetes or other environments you could also use HashiCorp Nomad as an alternative or AWS Fargate, for example. So you push your things into production using container technology. And this is the main use case where most of the magic of hackers attacking your applications happen. Sometimes they also try to attack CI/CD pipelines, because CI/CD pipelines often have a direct connection into your production system. Otherwise, it won't be possible to deploy automatically containers into your production if you won't have any connection between your CI/CD pipeline and your production system. But here also you have to make sure that you pretty shut off, you protect your CI/CD pipeline system against attacking. So especially the connection between production and the CI/CD system should be taken care of pretty much. So that should be as secure as possible. So now we have seen what use cases we have for using containers in Kubernetes. So what actually could go wrong if you're doing things wrong or if you're being attacked from the outside world. We had already several vulnerabilities inside Kubernetes or container technology in general. There are a lot of CVEs. This is a quite old one from 2 years ago, CVE 2018. But that also was a quite serious CVE vulnerability. And as you might notice already, so if there is any vulnerability detected for Kubernetes or containers, I think in 95% of the cases, it is a really serious problem that could lead to privilege escalation, gaining full admin privileges, host takeovers, and stuff like that. So most vulnerabilities that are detected are really dangerous for your production system. So always patch to the latest versions, especially for Kubernetes cluster and also all the container technology products. So as you can see here, for that CVE, for example, was 9.8 out of 10 as a severity score. But we already also have seen CVEs that had, in fact, 10 as a score. So the highest score that is possible, at least. Then, apart from vulnerabilities in general of Kubernetes, you could also do things pretty much wrong. Even big companies like Tesla did make things pretty much wrong. So they offered a Kubernetes dashboard that was pretty much open to everybody, exposed to the general internet with no authentication and elevated privileges. So everybody could just access the Kubernetes dashboard of Tesla. And also the hackers detected that. They pushed Bitcoin mining software to that Kubernetes cluster, which is the use case number one by attackers nowadays. They just wanted to push Bitcoin software to earn money, which is a good case for Kubernetes clusters. You can imagine that Tesla has a really big Kubernetes cluster that has lots of computing power, and that is a really good target for Bitcoin mining. And even worse, also AWS API keys and secrets are visible, so they can just jump over to other infrastructure using that public API keys. So always, if you're using dashboards that are pretty much used for Kubernetes, always check if the Kubernetes dashboard is secured by authentication and authorization. It should never be available without any authentication restriction to the public. So if someone can manage to access your Kubernetes dashboard and there's no authorization in place, the attacker could possibly manage your whole Kubernetes cluster and take it over completely and also lock you out in a special case. Also, as always for other software, look for open ports on the internet for your Kubernetes cluster. One very prominent port is the so-called etcd port. I will tell you a bit later more details on etcd, but for now, etcd is the central database for Kubernetes clusters that stores all the important configuration for Kubernetes clusters. So if the etcd database does not work anymore, your complete Kubernetes cluster does not work anymore. The complete configuration is inside there, and without configuration, your Kubernetes cluster would stop working. Also, all the secrets, all the credentials are stored in etcd as well. So that's why attackers also use that as a prominent target to attack Kubernetes. Because if you have the configuration part and all the secrets, then you don't have to deal with the normal use of Kubernetes, like using the Kubernetes API with authentication, authorization. You don't need to go over that API anymore. You can just access directly Kubernetes by stealing the secrets and directly using the configuration. One prominent page for hackers is shodan.io. You might know that already. And if you search for etcd ports, you will find lots of open ports inside Shodan that you can possibly attack and just grab the whole configuration, the whole credentials of that Kubernetes cluster. Luckily, there's also a tool available called etcd control, like kubectl. There's also etcd CTL tool available. And if you have detected an open etcd database, you could just check for cluster health, for example. And if you got healthy result, then you possibly can just access that cluster. I myself stopped at that point by checking, because if you now would go further in getting stuff from that etcd database, that would be illegal. So I stopped at that point, but you could easily just continue here and check out all the contents of that etcd database. So always put firewall rules, even for managed clusters in your cloud provider. Always shut down all the ports that are not required for the outside world. Well, the only port that is required to open actually to the outside world is typically the port for accessing the Kubernetes API. And also, of course, the ports of your application to access your application then that is deployed. So if we now have seen all that risks that can be provided by such containers and Kubernetes, so what can we as developers do in that case? So we will not talk about all that infrastructure basic stuff. So we won't talk about firewalls, about VLANs and networks in general today. We will concentrate on the developing part. What can we do as developers to make this a bit more secure? So this is the path for secure development for today's deep dive session. We will now start with the application security. and then go further to container security, Kubernetes security, and Kubernetes secrets. So when we talk about application security, then we have to talk about the typical web application security problems that are listed on what is called the OWASP top 10 list. So you might know already the OWASP top 10 list with the 10 most critical web application security problems. There are different ones, like we could have problems with authentication. Here, it is usually not the authentication protocol itself that is broken, but users using weak passwords, for example. Also, the other flows around the real authentication, like the security questions, are easily to guess. All that stuff is like resetting password flow is not implemented in a secure way, so everybody could just reset passwords from other users possibly. So these are the attack points, typically not the authentication protocol itself. So the OpenID Connect OAuth protocol is really hard to attack. So this is not the main target of the hackers nowadays. Then about authorization, we have to deal with all that access control stuff. So if one is authenticated in the application, can that person access, for example, the admin web page that is not intended for standard users? So is it checked, for example, that one user could access the shopping cart of another user, for example? So these are typical authorization failures. Then still the number one of the OWASP top 10 list is still the injection part, like the SQL injection. It is still number one, not because it's the most spread problem, but it is still the most critical problem. By just having one SQL injection in your web application, an attacker could possibly take over your whole database cluster, can then jump from the database cluster to the next server, and if you have a really insecure network backend system, then the attacker could possibly jump just through your whole servers and take over your whole network by just one SQL injection. That's why it is still the number one, just for criticality. Next thing would be rather client-side problem, the cross-site scripting attacks. If you use JavaScript pretty much, then you possibly have attack surface for cross-site scripting. Also for cross-site request forgery, these are typically problems when you provide a REST API that is secured by using session cookies. Then in that combination, somebody could just put a pre-built request in some famous forum, like if you're searching for cat photos, for example, also some other hobby stuff, you go to a forum and the attacker does some social engineering before to get to know what are your hobbies and stuff like that, and it puts some prominent web link in that forum that you don't recognize at once because it's behind a photography of a cat, for example. Then you click on that cat, and behind the scenes it just executes a use case on your web application by that URL. And if you are logged in via session cookie, then probably that request just goes through because of that session cookie automatically be sent with that request. Then also data protection, crypto stuff is really important to do things correct here as well. Especially in Europe, we have that pretty hard data regulation protection in place. And there you have to protect your application data by using cryptography. So these are all pretty much problems of your web application. You might also know what is called the testing pyramid. That was originally shown first time by Mike Cohen, where he showed quasi that on the bottom you should have a safety net for all your testing, for all your unit tests, to make it possible to even do refactoring in your application. If you don't have a safety net of lots of unit tests with fast feedback, if something is broken in your application, then it is really difficult to really refactor your application or adding different things, updating functionality, if you're not sure that this breaks some other part of the application. In the middle, you have the API service tests that are require a bit more effort to implement and also have a slower feedback. These are operating typically on the API service, like for example on REST API level. And on the top, you have the dynamic stuff. You have UI testing, for example. And on the very top, you have the manual stuff, so that not automated stuff, usually like explorative testing. And on each level, you can also easily test security, which is not done pretty much as I see in projects, but it is possible. You can just test how good is your input validation, for example, working on the unit test level already. So if you're using bean validation standard in Java, for example, you can also instantiate the bean validation factory in a unit test already and just check for correct input validation. Also for authentication, output escaping, also bypassing business logic in a unit test, you can easily test that on unit test level. Also checking for error handling and logging if that happens in a correct fashion. So especially you could check if the logging output does not log sensitive data like user passwords. You can also check for that on unit tests already. Then especially for security testing, you can also do static analysis on that level, like using spot bugs, for example, or also later container image scanning would also be on that level, or checking your dependencies, like the Hibernate framework library for security problems using the OWASP dependency checker, for example, or the Node.js, the npm audit command could be part of that unit tests level. On the API service level, you could just easily test for the whole real authentication part, like also doing validation of your authorization permission model, by also using positive and negative tests on that level. So always do a positive test if a user with the admin role, for example, has access to a special endpoint, but also do the negative test if the user does not have the role admin, that you get an access denied exception, in fact, proving that nobody else could just access that. You can also easily, for example, test SQL injections in integration tests. Just try to put a typical SQL injection pattern like the famous and 1 equals 1 snippet, for example. Just try to put that in your tests inside a request to your database, and then check if your database behaves like expected, ignoring just that input change for the SQL statement, or if it really takes it into the SQL statement. Also, you could check if typical response headers are set, like the strict transport security header, or you enable the XSS protection of the web browsers by the specific XSS header set in the response. You can also check for that. On the top level, you can run dynamic application security testing, like using the OWASP SEP tool, which is an open source penetration testing tool that also provides Docker containers. Here we also use Docker containers. With the Docker containers provided here, you could easily do some baseline scanning, which is quite fast. That typically only does some passive scanning on that level to have a fast feedback if there are low-hanging fruits to be detected regarding security. Then you have a special API check command available, and you also have a full scan command available. So for the baseline and the API checks, that could be easily integrated in your normal CI/CD pipeline. With every commit, you could possibly run behind the scenes that dynamic scanning. The full scan should only be done in nightly builds, because the full scan might run for 30 minutes or even hours, depending on how big your application is. And on the top level, you could just also use it in explorative testing. So by adding special security charters in the explorative testing part. So it would be an idea, for example, to have a session with your developers, also with your customers, your stakeholders maybe, and just do a 2 hours testing, for example, and everybody just tries to put as much rubbish chunk into all input fields that he or she could possibly find in your web application, and then check how the web application behaves. If you just put some emojis inside, put some SQL injection payload, some cross-site scripting, some strange characters, just check out how it behaves. That could also do a normal stakeholder could also test things like that. So these are all ideas how to test your application already for security. And then also automate all the things. So you can easily automate all the things. So static analysis can be automated in your CI/CD. Then dependency check can be automated. Also dynamic scanning, like doing that stuff with the OWASP Docker containers. All the stuff could be easily automated. Now we'll just dive into some practical part. As you can see here, this is the GitHub repository I have mentioned. So if you look into github.com, Andy Falk, which is my user there, then secure development on Kubernetes, you will find the repository here. If you want to do all that labs inside that repository, there's also a special section on the requirements. You find the presentation slides here. Also helpful tools for Kubernetes security. I will tell a bit more about that later. So if you want to run that sessions later, especially when it comes to the part of Kubernetes, you should have a Kubernetes cluster at hand. Now for that labs, you won't need a full-blown Kubernetes cluster like a Google cluster or Azure cluster. You can easily just try it on your local machine by using Minikube, for example, or also by using a tool called K3S. These are free Kubernetes clusters that can be spinning up on your local machine very easily. Just download it. Here you can also consult the docs of Minikube. If you have downloaded Minikube, just start it. Then you can also use the Docker registry inside Minikube if you don't want to use remote images. If you just want to use local build images, then you can also use that. As well, K3S is easy to use, or just use a managed Kubernetes cluster for that labs. This is also what I will do for now. So I will already prepare some cluster for the later labs already, because creating a cluster takes some time. Now before that, I should probably log into my environment before. So it takes some time today. That's strange. So now I should be logged in. So now I can just create my cluster. So I will start it now and leave it running, because it takes some time. I also can, in the meantime, show how this command looks like for creating such a cluster. So in fact, I will just create a Kubernetes cluster on the Google Cloud environment. In that case, you have to give a zone where that cluster runs. So I'm in Europe, so I take a zone nearby me, so West 3, I suppose it's in Frankfurt, Germany. Then you have to give a cluster version, what Kubernetes cluster you want to use, a machine type. Then you probably also need to specify how many nodes you want to use. I have now spinning up 4 nodes. And one interesting thing that also is for later for using Kubernetes secrets is that part here. I also switched on the application level encryption for Google Cloud Kubernetes cluster. That pretty much encrypts all the secrets on their way from the etcd database or back to from the etcd database. So in transit, it's also encrypted and decrypted on the way. So it's more difficult to grab a clear text secret anymore. So that was that case. So the other part would be some helpful tools that you could use. I will just go into details for that later stage. What I now want to show is our sample application. For the whole deep dive session, I have built a really simple sample application. You will recognize it is a typical Spring Boot application with some configuration properties. So the greetings, so it's a greeting application. So you can just configure the greeting and the default greeting message, for example, or there's also some for a secret that should not be shown on the screen. And you have a typical greeting REST controller here running that just points out a greeting in that case. As you can see here, I also use output escaping here, output encoding by using the OWASP Java encoder in that case, that encodes for HTML and for JavaScript. So with that results returned by my REST API, it should not be possible to do cross-site scripting attacks anymore, because I encode all the things, so it's not dangerous JavaScript or HTML code anymore. And there's a second type to access it, so you can also give a request parameter, so you can also give a user-defined message to that application, and that's all the use cases of that application. So it's pretty simple because we don't want to deal with complex use cases today. We just want to use a simple application for our cases. So if we just look into the application, so I can easily just put some message here. As you can see, also these things here are already encoded, so it's not possible to use that directly. So hello Devoxx could be a possible message. But you could also, for example, try to put some script inside here. So the typical cross-site scripting attack that is used in input fields or in URL parts. So as you can see, it is encoded, so there is no pop-up coming up in my browser, so no cross-site scripting is possible at that stage. So that would be one example how to secure your application against one of the OWASP top 10 attacks. For easiness, I have not put authentication inside that application. because it takes some time to always put in username, password, and we don't have that much time today. So that was the first part already. Not completely here. That was the first part of the application, just doing the first iteration about application security. We have seen that Hello Spring Boot application. These are the endpoints. What I have not shown is the actuator endpoints. This is also security-wise could be a dangerous thing. So if you enable all the actuator endpoints in your Spring Boot application, it could also be a prominent attack surface for attackers. Like for example, especially the environment is really interesting for attackers. So if you don't protect that endpoint with the environment variables, then this could lead to just publicly available sensitive data. So you can also look for some secure. I don't have. Yeah, as you can see, you have all the values put out here. So you can imagine that if you have some passwords, some sensitive data configured as environment variable in your application, then this would also be put out on that part here. I'm just searching for my own. So this is, for example, what I'm talking about. So if I have my secret sensitive data, which should not be shown in clear text here, but it is shown on clear text here, you should be aware of the actuator part, that it also can show sensitive data if you're not protecting this endpoint with authentication. So you can also use that on command line for sure. I've shown also that the script alert part. You could also try to redirect using such things. That should also not be possible. Yes, we have also spot bugs inside. We have dependency check built inside, so I can just show how that looks like. So putting a dependency check is quite easy. Just put a Gradle plugin that's also available as a Maven plugin. Put some configuration. So here I tell it should fail if a CVE score is above 8, which is high critical, then it should fail the whole build in that case. You can also add suppressions for false positives as well. And here's also configuration part on the spot bugs part that puts out also reports if there are some problems detected in the static code analysis. So these things are really easy to configure, and I would recommend to use them in all your Java projects as well. So this was the application level part. So as a summary for application security level, always use do input validation for all types of input. Also use output encoding, as we have seen, for prevent XSS attacks. Always use parameterized queries, prepared statements for accessing data. With databases, enforce authentication and authorization for all parts. Also, never implement your own cryptography or session management. Use frameworks for that. Use well-known cryptography algorithms and implementations. So also a bad source of doing cryptography wrong is like Stack Overflow, just copying over some prominent cryptographic algorithm of Stack Overflow. Especially there are still lots of misguiding entries in Stack Overflow, telling, for example, that base 64 encoding would be a encryption algorithm, which is is not the case, or just offering cryptographic algorithms like a CSAR algorithm, just shifting some characters. That is also not a secure cryptographic algorithm. And also check third-party dependencies for vulnerabilities, and always also use static and dynamic application security testing. That was the absolute basis. If you have now a secure application that you can put inside a container, then you can go ahead. We will now talk about container security. The good point here is when we talk about container security, you find plenty of good sources on the internet already dealing with that, giving advice how to secure your containers. For example, there's a NIST special publication by the National Institute of Standards in the US talking about application container security as a guidance. Then also the OWASP, in fact, offers two types of documents. One is the OWASP Docker Top 10, a special crafted Top 10 by the OWASP for Docker. And they also provide a security verification standard document for containers. And they have the standard security verification standard for web application part. They have one for mobile applications, and they also now have one for container security. Here you can find typical requirements regarding container security and also how to test it. In Germany, we have the so-called Bundesamt for Security in the IT. They also provide some document for our German people, for example. So I would suppose that in your country, you would also have a corresponding regulation stuff or corresponding part of your government that deals with information security that maybe has also a similar document talking about how to secure in containers. Especially the OWASP Docker Top 10 also has 10 prominent parts, which we also strive today, like secure user mapping or patch management strategy, secure defaults and hardening, for example, maintaining security context, also protects your secrets. Also dealing about container image integrity and origin, following the immutable paradigm. So containers should also be immutable, so it should not be changed and patched. The containers should always create new containers, for example, and also dealing with logging stuff. Now I will have a short introduction into how containers work and how they differ from what is called a virtual machine, because lots of time I still see a lot of misunderstanding, and so a lot of people cannot distinguish between a virtual machine and a Linux container, and these two things are pretty much different. For example, especially when it comes to security and to isolation part, these things are completely different stuff. So I often read containers are lightweight virtual machines, which is also not true. So virtual machines are one part and containers are another part, and these are completely different approaches. So if you look for virtual machines offer a much harder isolation than container ever could possibly offer. So you have, in fact, two types of virtual machines. You have what is called a virtual machine with a hypervisor, and you have just a virtual machine that has no hypervisor but has some virtual machine monitor sitting above a host operating system. So if you look at VMware ESXi, for example, Xen or Firecracker, Hyper-V, these are built upon a hypervisor that sits directly on physical hardware, and that hypervisor deals with the whole isolation of virtual machines. So you see, there's no unique kernel and stuff running on an operating system level. You have the hypervisor, and above that you have the different guest operating systems that then run some guest applications. In the second alternative, you have the physical hardware, then you have a host operating system running, you have then the virtual machine monitor running above that. So that's a bit more into the direction of containers, but still has much more isolation than containers because you are not running on the same Linux kernel in that case, as it is the case for containers. We will see now in the next slide. And above that virtual machine monitor, you have running your different guest operating systems and your guest applications. So a prominent thing here is VMware Workstation, for example, or VirtualBox by Oracle are typically such products that run in that type 2 fashion. But alternative 1 and alternative 2 offer strict isolation between your guest operating systems. So it's not possible to see a process running on one guest operating system on the other guest operating system. We will now see how this looks like when you're using Linux containers. So for Linux containers, they don't have a virtual machine orchestrator or something like that between. They just run on the same Linux host, the same Linux kernel. So they run on one physical machine that runs one operating system, just one Linux kernel is running there. So we have only one physical machine running all the processes on that machine, on that Linux kernel. So the container share all the processes running on that Linux kernel. So you can also easily see a process that is running in container A. You can also see that process on a Linux host, and possibly can also access that process. So that's why the isolation is very weak compared to virtual machines. And what the attacker wants to achieve here is breaking out of the container and accessing the Linux host. So that's the main target for hackers when it comes to security of containers. So containers, in fact, are isolated using what is called Linux namespaces. You can control resources on containers using control groups. We will have a bit deeper dive in the next slides about that. Then what is called Linux capabilities is also a mechanism to isolate and to restrict access to containers. And then you have the higher level possibilities to further restrict access, like using mandatory access control, secure computing mode. And you also can use container secrets management inside Docker, for example. Important to mention here is also that Docker is not the only container product available on the market. We have a standard built by the Open Container Initiative, and we have different products like XHT or LXD that can also be used as an alternative to Docker. Nowadays, Docker is still the most prominent one, but there are also alternatives building on the same mechanism than Docker does. So when it comes to Linux kernel namespaces, so this is the number one isolation mechanism that isolates the different containers on the same Linux kernel. So every container can have its own process IDs. Every container could span its own network stuff, can mount its own file systems, have its internal inter-process communication. Every container can have its own user and group IDs, set its own host and domain names. So you typically see some ID as host name set in a Docker container. So every Docker container has its unique host name set. And also a control group, which controls what resources a container can consume, is also a namespace. You can easily just query for namespaces. In that case, we will just jump over the surface pretty much for hackers. If a hacker gets grab on your Docker container with a privilege flag, then it's much more easy to break out that container and be also privileged and root on your host system. For example, when you use privileged mode, you could just easily use a command like fdisk. You can pretty much change the partitioning of your container. So as you can see here, it just prints out some fdisk commands. So that would not be the case if you would run it without a privileged flag. Then you could see you just basically see nothing. The fdisk command just won't work in that case. So as you can see, it could be pretty much dangerous to then execute reboot commands, fdisk commands, or just mounting different file systems. So also be possible to mount host file systems and then access these host file systems. Playing around with socket stuff, with Docker socket stuff, and really dangerous things could happen. So this would be another command which you should take notice of. I mentioned that you could just drop all the capabilities and then specifically add that capabilities that you need for your container. Like, for example, the netbind capability. So if you just use that one, you just drop all the capabilities and just use that capability, then you see here that the current capabilities now is only the cap netbind service. Just one capability, and that's much more secure than just using the default or even using the privileged ones. Because what attackers want to achieve are privilege escalations. So to be root and just break out of the container. You can even make it more secure by adding another option like no new privileges set to true. Then it would also not be possible to misuse setuid binaries, for example, to gaining new privileges. So that would also be prohibited. So we have also the Linux mandatory access control system calls. I would skip that part for now. I just would mention that with gvisor, for example, you could have sandboxing functionality where you can sandbox your container in another sandbox. So the breakout is even more difficult. But we will now deal with Docker images. So this is how containers and images are working. So usually you build your own container images, which are usually built by using a Docker file. In a Docker file, you have to specify some base image, like using Alpine, for example. You could also use Ubuntu, distroless images from Google, for example. Then use a Docker file to describe what packages you need in addition to your base image. And then also your application will be packaged into that container image. Then you will build that container image, put that image into what is called a container registry. And then if you use a Docker run command, this just grabs it from the container registry, that container image, and then runs that container image in your Docker environment. Just using the concepts like namespaces, C groups, and stuff like that behind the scenes on your Linux host. So that container image uses the isolation by provided namespaces in that case. So you could break a container isolation by different things, like containers run as root by default. So you have to be aware of that fact. So if you just run containers, these are always run as root with that standard capabilities set by default, which that we have shown. If you use the privileged flag, then you would have the full capability set to the Docker container. You should also be aware of that mounting sensitive directories could be a dangerous thing, like mounting sensitive directories to for example, the etcd password data store and stuff like that. Also, mounting the Docker socket could open up a attack surface, because a very prominent use case is using that approach into CI/CD system to connect to your Jenkins slaves, for example, using Docker socket, which is a very easy approach, but it's also the most dangerous approach, because basically everybody who has access to the Jenkins file could then just also play root via Jenkins file commands, going over the Docker socket to the Jenkins node, and then has root access to the Jenkins node and can pretty much also execute commands in root privileged mode. So there are also other possibilities provided by some Jenkins plugins not using the Docker socket. Also, shared namespaces would also be a attack surface, like here, for example. So you can just mount some host root file system, and then you can just also access all the host file systems. Then all is root is also anti-pattern you should not use. I will show how to make it better. In that case, how to be not root on your Docker file, it's quite easy. Just add additional user in your Docker file, like it's shown here, like run add group and add user with a user ID of 1002. So a good advice is also always use user IDs above 1000. Because beneath 1000 user IDs could be system users, and you don't want to have a conflict with some predefined users. So just use a higher user ID in that case. So we have added an app user, a special one, and then we, by the user directive with user 1002, we just advise Docker, please use that user for running our Java application and not the root user anymore. Now this is a typical Docker file using OpenJDK and just using our Hello Spring application as a sample. It gets also more easily if you use what is called chip plugin, which is provided by Google, and distro-less images by Google. Here you have two advantages, not only security-wise. One advantage is that you get much smaller container images when you use that approach with distro-less images, because distro-less images just put inside a container what is really needed to just execute your application. So imagine you're not building a Java application, you're building a Golang application. It just puts in the statically linked Golang application and pretty much nothing more. So there is no shell available, there is no full-blown operating system binaries and stuff like that available. So you can not perform a ping command, not perform any other stuff, open a shell and stuff like that. So just the required components that really required for just executing your application, nothing more. So this reduces the attack surface pretty much. But it makes also things a bit more difficult. If you want to debug your container image, then you cannot access that very easily. One other advantage is that it can increase your development turnaround pretty much time-wise. Because one point is that you don't need to have Docker installed at all on your machine. So it does not need a Docker daemon anymore to build Docker images. It just uses that plugin and that builds the images, and it also builds the images in an optimized fashion. So it recognizes that you didn't have changed your used third-party dependencies, for example. You only changed application code. So the layering in Docker containers are optimized by that tool. So it just builds the top level layer again and recognize that. So it's much faster in building container images and getting smaller images. So you get distro-less base images for all the programming languages like Node.js, Golang, Java, stuff like that. My recommendation would also be to use distroless images as base images, so it's a bit more secure as well. And here you can also specify user 1002, for example. You have also the advantage here that you don't have to add that user beforehand. Just specify a user ID here, and it won't take the root user anymore to execute all this stuff. So this is a recipe for secure Docker run. Basically, don't use the privileged one. So that would the worst case that you can use Docker run with the privileged flag. So the default one, Docker run, is also not very secure. A bit more secure is the Docker run with the security options, no new privileges. Even more secure is by just dropping all the capabilities and just adding a specific capability. And even more useful and more secure, also resource-wise, is that you also restrict using your resources by using only half of the CPU, for example, and only using 200 megabytes of memory for your Docker. So that would be the best thing. So Docker would love that command pretty much. So that's a small recipe to make it step-by-step more secure to run your Docker containers. If it comes to Docker images, to especially Docker base images, you also have to be aware that there can be base images on Docker Hub, very prominent ones that have lots of vulnerabilities inside already. So the top one with the most vulnerabilities from the last report done by SNCC is the Node.js base image. So that had originally 580 vulnerabilities inside. You can reduce that vulnerabilities by using different variants of Node.js base images, like using the Slim variant drastically reduces the vulnerabilities number, and even using the Alpine one reduces that in that case to 0, so much more secure than just using the standard node image. So always also check if there are better alternatives for using different Node.js images. And also MySQL, you see all the prominent base images like MongoDB, HTTP, Nginx, stuff like that, Redis. All these have vulnerabilities inside. Luckily, there are also open source image security scanner available, open source ones, commercial ones, like Trivi, for example, or Claire or Anchor. They all provide open source scanner that can be just used for free, for example, in your open source projects. And these scan your container image for 3 different parts. It's on 3 different layers, as I might say. It checks for operating system vulnerabilities and also for vulnerabilities in your third-party dependencies that you use in your application. And it checks that on different levels, like, for example, use base image on the parts that you add in your Docker file and also for your application. What is also a good choice is to use, for example, your own container registry. So especially in my projects where I use big customers, they always use their own registry, their private registries. Here it is absolutely prohibited to load any base image from the Docker Hub. So all images, all base images are inside that private registry. They are pre-checked. Some base images are specially crafted by that company, for example, like base image for Java, for example, should only be taken from that private registry. And if you want to use your own on-premise registry, for example, or push that easy way to your cloud environment, then you could use Harbor, which is an open source registry. That to the next part, to Linux container basics, I have prepared some some short parts here. I've also prepared a part describing setuid and setgid part, which is also a security problem, which can be a problem in containers. You might already know about that setuid flag that you can set as a permission to your files. And if you set that setuid bad sets, then that means that that independent of who actually executes that file, it will also always be executed in that user context that has set that setuid flag. So, for example, if I do sudo my sleep in that case, and I have changed mod with the setuid bit set, even if I start that with sudo, that my sleep will run under my user context. And so that's typically a thing that also is used by attackers in containers. Just looking for binaries that have that setuid flag set, which could be run as root user, and they then try to misuse that binary to gain access as a root user, especially gain access to the host as a root user, then to break out the container. And by using that binary with the setuid flag set, then using that one to jump to the host and have root access to the host as well. That's why also some container image security scanners also report on presence of files with that setuid bit set, for example. What I now want to tell you is that part on Linux namespaces. You can, for example, simulate somehow that isolation regarding host names on your Linux host. So I just try to use that one. That's finished here. So if I just use that unshare command, so with unshare, you can pretty much do some isolation and use and unshare quasi with that namespace. In that case, that UTS namespace to set your own host name from the parent operating system. So I now will open a shell. And in that shell, I have my own host name environment. So as you can see now, it still has the host name of the parent, but I can easily just set my own host name here. Now, so I should now have host name isolated. And if I go there and my parent and just type in host name, it still has the original host name. So I have isolation via host name namespace in that case. So that's a poor container simulation now for host name. But you can imagine you can do that for all the other namespaces as well. And that, in fact, is done by your container technology. So the containers are just isolated using such namespace as I've used here. You can exit that again. And if I give host name again here, so it still has the old host name. So it was not influenced by that other namespace that I have started here. And you have different namespaces as I've shown here that you can easily use here. I've also mentioned already the next mechanism called Linux control groups, which is also a namespace. With Linux control groups, you can restrict the resource limits of your container, which is also very important. So you don't want your container to consume all the resources that are available on your host. Then it would not be possible to start another container on your same host. And usual use case is that you have running several containers on the same host. So you can restrict using the CPUs, using memory, devices, processors, and network. If you are a Java developer, the important stuff here is if you want to use resource limits and using Java, then at least you have to use OpenJDK 8 update 192 or above. So recommendation would be to use Java 11 at least. So Java 8 is really old, really legacy. We have Java 11 now for a long time already in place as new long-term Java, and I would recommend use Java 11 because Java 11 is the first Java version that is really container aware from scratch. So OpenJDK just got backported some stuff from the Java 11 part in that case. So if you use an older OpenJDK like 8 update 140, for example, or even OpenJDK 7, then you would end up that the Java would just ignore the resource limit set and would just grab the whole resources of the host. So if you look into that Java application, then it would probably consume 2 gigabytes of all the host memories, for example, or the whole CPU. So recommendation is to use a recent OpenJDK version like Java 11 and just go forward. So Linux capabilities is also a very important concept used by containers for security. In previous times, in previous older Linux versions, older Linux kernels, you only had 2 choices. Either you are a supervisor, a complete root user with all administrative privileged access available, so you could possibly do all the things on your machine as root user, or you are a standard user that has pretty much no privileges, just running some standard applications, but not going further into some privileged access. So you had these 2 choices. Now with Linux capabilities, you can tune that and fine grain your privileges that you have. So even for a normal user, you could just set some capabilities to a file or to a thread, and then give some other privileges in addition to the standard one. So in standard, the files or threads that do not have any capabilities if they're run by a standard user, but you could easily just add, for example, the capability called netbind service, for example, to a process, or by running Docker, you can also, as you can see here, do a cap drop all to not give any capabilities and then just add a specific capability for the netbind service. So in that case, netbind service is a very important capability because netbind service makes it possible to bind to a port beneath the port 1024. As you might know, all ports up to 1024 are privileged ports that a standard user is not allowed to bind to. And as you can imagine, you have, for example, an HTTP service that is run in Docker like Nginx or Apache that typically uses port 80 to bind to. For these applications to run inside Docker, you would need that netbind service capability at least. So it is possible to bind to port 80. I've also prepared some practical stuff on that. As you can see here, there are lots of capabilities available, like a capability also to be get owner of some files. There's also a capnet admin, so to have like admin rights on all network operations. So you can also modify routing tables. That is, for example, a typical capability that is used by service mesh frameworks like Istio, because they want to modify routing tables, so they need capnet admin as capability. Then you have capnet band service, as I've shown already. Also, capnet raw is a really important one. For example, if you want to use the ping command, that typically has the capability capnet raw to open a raw socket, which is required to do the ping command. Cap sysadmin is a capability having lots of other capabilities. So if you are root, then you typically have that cap sysadmin capability. So that is the capability that gives you all the privileged access you need as a root user. Then you have capability to reboot your system, for example, which could be dangerous to some part. You can change root, for example, to give another root file system. You can change the system time, or also access privileged syslog operations. So the system log is also a privileged part. Not everybody could just access the system log. So for example, you could just try, for example, to use get cap on the ping command. No, that's strange. That's strange. That works yesterday, so I don't know why this works. It does not work now. But I have ping available. Oh, that's strange. Yeah. But that's the demo part. But you can also set the capability for mapping, for example. You can also use that for running processes, for example. If you have a process ID, you can just also call that. What is more interesting for our parts to use it in Docker world, you can also print out capabilities of Docker. Then you might notice that Docker by default adds default capabilities as a standard to your Docker containers. So if you just run a Docker container with nothing else changed, no special configuration, it gives the Docker container already a predefined default set of capabilities. And by just running that command, we could easily see what are the capabilities. So I hope this runs now. I have to pull it. So as you now see, these are the capabilities that are set by standard of Docker if you don't configure any other thing for Docker run. So as you can see, you also have the cap netbind service by default. So that's why by default it is possible to use Nginx or HTTP server as a Docker container, because it can bind to port 80 by default. It also has capnet raw to do some routing stuff, for example, also change root. So typically pretty much balanced default sets between usability for Docker and between security for Docker. So that's really a balanced set between these two topics. So with less capabilities, the standard user might not be aware of that capabilities and cannot do things he was expecting to do. So if you now try to do the same in a privileged mode, like running with root access capabilities, then things change pretty much. So if you now try to operate it that way, now you can see if you just add the privileged flag to your Docker container, then Docker gives you pretty much all the capabilities. So you are full-blown privileged user now on Docker containers. And this is a anti-pattern you should not use for your Docker containers. So there is almost no case that you should use privileged as a flag here. So that is really dangerous. It opens up the security of my application running in Kubernetes. then the replica set is the main thing that handles that always two instances are running. You don't handle that directly in Kubernetes. What you manage is usually at what is called a deployment. In the deployment, you tell, I need two instances, and behind the scenes, a replica set is built, and that is then controlled by the Kubernetes schedulers that look into replica set and always check, do we have running two instances? No. Okay, we have to spin up another one to confirm to the replica set. To open up your application to the outside world, what you will need is a service. So a service is what is called somehow a TCP IP layered load balancer that opens up your private pods to the outside world, and it cooperates usually with what is called the ingress service that opens up the ports to the outside world to your service. So your service always also deals with finding your pods. So if you have several instances, it does a load balancing over your pods you're running. It just uses one of the pods, and the ingress just opens up a port to the outside world, for example. And this is usually done by your cloud provider and handled by your cloud provider. So this is a really fast overview. What is more important for us security-wise is that Kubernetes opens up lots of attack vectors now. This is taken from an O'Reilly book, Kubernetes Security, which is freely available. You have plenty points to attack a Kubernetes cluster. Like, for example, as I've told, the etcd port, for example, you can attack over the API of Kubernetes, what is called the control plane components. So Kubernetes always has two node types running, one master node, a control plane node, which is to control the whole cluster, and the worker nodes where you put your pods, your applications into. And you can also access machines, VMs inside here, which is one case that the attacker wants to achieve. Intercept control plane traffic here. Access the kubelet directly, which is the component that takes care of running your pods on the worker node. So attacker could try to communicate directly with that kubelet without going via the API of Kubernetes, or by using container escaping, get access to your node directly, so to the host directly, and then do strange things on your node, like, for example, also putting another Docker container directly on the node, doing Bitcoin mining. So this is a visualization. So what is usually operational work on your Kubernetes cluster, and what is the development part of your cluster? So as you can imagine, the operational security part of Kubernetes is even more work. And even using a managed Kubernetes cluster by cloud providers, you also have to deal with VLANs, with firewalls, with load balancers to initially set up your Kubernetes cluster in a correct way. So you also always have to take care that there is a firewall in place, that all communications are using TLS, they're all secured with HTTPS communication, with server-side certificates and client certificates. Always use authentication and authorization when communicating between master node, worker nodes, and also for the API server. You can also read these things in the Kubernetes docu, in the 4 Cs of cloud native security. And for us, the rest of the minutes we have, the important stuff is the development security of Kubernetes. So what you can do as a developer also in Kubernetes is, for example, the easiest part is switching on, for example, Kubernetes auditing. That is usually only a checkbox when using a managed Kubernetes cluster. Then with auditing switched on, you get a log of all the actions happening on your cluster. So if anybody pushes a new pod, if deletes a pod, changes a pod, all the actions are audited in detail. So you can recognize if some other people that are not supposed to do anything on that Kubernetes cluster, you would recognize that by looking through your auditing log. So that's a really important point, but very easy to solve. Then also Kubernetes provides authentication, authorization. You can do the same stuff that you have done on Docker. You can set resource limits, but by using pod security context, pod security policies, you can restrict your containers from running with a root context. You can drop capabilities. There's a newer approach called the Open Policy Agent, which could also restrict access to your containers or enforce some policies, so you cannot deploy any containers anymore having root access, stuff like that. And also you can restrict communicating between pods, for example, using network policies. So these are the base concepts you could use to restrict all the security here. For authentication, you have to take care that there are typically two categories of users on Kubernetes. There are service accounts that are managed by Kubernetes itself. These service accounts are corresponding to your applications that are running. So each application has at least a service account by default. And then you have the normal users with typically different roles on your cluster. You have different authentication mechanisms. I will not go deeper into that part because usually the authentication strategies are configured by your cloud provider already. So cloud provider, you can configure to use client certs, to use OpenID Connect tokens, for example, for authentication. So bind the identity management part of your cloud provider also to the Kubernetes authentication part. When it comes to authorization, you have to get to know how the role-based access control inside Kubernetes works. So basically, the most important thing here is that you have to deal with the service account level and the user level. You should be taking care of that. Not every user should be a cluster admin, basically. So also use fine-grained authorization for your user operating with your Kubernetes cluster. For example, you could also give a user only a role for one namespace. So you can split up the namespaces in the Kubernetes cluster for different development teams. And via role-based access control, give them only access by some role to one namespace. Only a few users should have cluster-wide admin access. So to reduce attack surface. So role-based access always works in the same way. You have a subject to bind your roles to, and on the other side, you have target resources to bind the roles also to. So the subject can be a user, group, or a service account, as already told. Then you have cluster-wide roles, or you have namespace-bound roles. And with role binding, you bind your role to a subject, and you can specify roles then for your target resources. And the target resource can be an API group, it can be resources, all resources like a pod, like a service, like Ingress, like all the Kubernetes services can be bound to a role. And then you have verbs, what action to take on a resource, like you can, if you can create a pod, can get read a pod and stuff like that. So that was the authorization part. Then when it comes to resource limits, so that's the same as you would set for Docker. You can just set CPU limits and memory limits. You can put hard limits, so the limits that cannot be over committed. So if you want to use more than one CPU, then your container would be killed. And with requests, so these are the resources that you need at least for starting your application, for normal operation of your application. This is what is called the container security context. We won't have time for showing all the labs now at that stage, but you can have a look at the GitHub repository for yourself afterwards and just try that labs for yourself to put that inside Kubernetes. What you can set here is basically that you tell that it should run as non-root, then it should not allow privilege escalation via setUID, for example, It should not use run privileged, so that's the same flag as you use on Docker. Again, run as non-root for that container. So that the whole thing here is for the whole pod. And this thing here beneath here is the run as non-root, especially for a container, because you could have several containers. So you can already restrict your whole pod from running as non-root. Then also recommendation is to use read-only root file systems. So if you need some write access to some temporary directory, then a good approach would be to just mount a temporary file system directly, but not use the root file system for that. And then drop all the capabilities you don't need. So you can also easily add one capability then, but dropping all capabilities is a usual case. So lots of containers won't need any capability. And the pod security policy, so that was a security context that you have to set for each and every container in a special way. So, but it's easy to forget to add a security context for each container. So the other approach would be to put policies cluster-wide instead with using a pod security policy. So the Kubernetes documentation specifies 3 different approaches here. So in some rare cases, you need to have a policy that allows privileged containers. Like for some infrastructure, like putting FluentD stuff for grabbing log files from syslog. These would need privileged access, but these are only very seldom cases where you need that. Most containers should use at least the baseline, which restricts it a bit more, or even better, the whole restricted one that does not allow any privilege, any root user as for the containers. And the pod security policy looks just almost the same, like a security context. You also specify privileged false, don't allow any privilege escalation. You can drop capabilities, and you specify that it must run as non-root. And this is called a no root policy as name, for example. There's also policy auto selection criteria. I will skip that. And now it comes again the part of role-based access control. You have to bind your policies by using service accounts to your specific pod. So you declare some pod security policy. You specify a role for that pod security policy as a target. Via role binding, you bind that to a service account and you specify that service account in your pod. And then you're using that pod security policy. Because when you enable pod security policies on your cluster, as soon as you enable pod security policies there, you won't be able to deploy any container on that cluster if you don't bind to any provided pod security policy. This all sounds a bit complicated. It is quite complicated to get that all right. That's why I will skip that for now. We have a newer approach called the Open Policy Agent, where you just also deploy some additional admission controller to your cluster called the Open Policy Agent, where you can just write rules for yourself. So don't allow, for example, root containers running, where you can also have a playground to check these rules. And then you can install a Kubernetes gatekeeper that uses the open policies as an admission controller and then always checks each and every deployment here. Also check if you're using Helm 3, because Helm 2 is also playing root on your system. So we will skip that for time reasons. Summary is here: follow Container Security 101 as I shown, use a managed Kubernetes cluster, enable audit logs, use authentication role-based access control, use pod security policies or the Open Policy Agent as an alternative, upgrade to Helm version 3, to remove tiller, which is playing root on your cluster basically, and also always monitor your Kubernetes cluster. So if one offers all the recommended patterns already, so it secures artifacts with policies and role-based access control, so not everybody could access them. It has image scanning on board. You have the choice between Claire or Trivy nowadays to configure. It also includes signing images with Docker Notary Trust standard. So you can also sign your image as trusted. So you can check if the image was not changed after the creation of that image. So no third party could just put malicious code inside a pre-existing container image. So also use that one, for example. Also, Docker and Snyk announced a partnership to put the Docker image scanning command directly inside Docker, which is already available as a beta version for Mac OS and Windows. For the standard installation on Linux, it is not yet available. So if you're using a beta version of Windows and Mac, you can just easily use the command docker scan now and just directly scan images with the Docker command. You don't need any third-party scanner anymore. So let's jump into that part. That would be the second lab, like a root container. Here we have built a root container of our application that I have shown already. We are using OpenJDK Slimbuster variant for as a base image here. To make a standard Docker container image, there is a Docker Gradle plugin available that you can use to build that Docker image. I think it's not described there. No, it's not described. If you want to use that yourself, you just call that build Docker build file. I've done that already, so what I would use now is that I would use that already built your Docker containers. Just have to log in. I just already logged in. So for example, the Hello Root application I just built yesterday, I think 13 hours ago. I've pushed the latest one already. And as I've told you already, that container, if I just run that container now, that would run with default as root. Let's just try that one. Now I have to stop my application running. That's a thing that I always forget. So I already have run my application here. And try it again. So now I have running my container. So if we now go to the application, so that should still be running. What we now see is the running application running in the Docker container, not the application in my IntelliJ anymore. And if we now wanted to check what is the user actually executing that part, then it just types out, it is really the root user that executes that part. So it also uses that capabilities as we have shown before. Nothing special here. What we now also can do is checking that image for vulnerabilities. I'm using Trivy in that case, for example. It's always a good advice to clear the cache before running Trivy against your container. And then we just want to execute the image scanning to not be overblown by plenty of reports now. We just scan for the high-end critical ones against our own container image. As you can see, it's just the first step is to download the newest information security-wise from the database. What are known security vulnerabilities for container images? Then it scans the image, and as you can see, we have different CVEs detected here. Even if that is a pretty new image, so I've used the most recent OpenJDK base image in that case, but it still has also some pretty old CVEs. And the recommendation here is now you have to look through all the CVEs that are reported and take into account if that CVE is applicable for your application. Like, for example, that CVE is quite old and is not applicable for our application because we won't compile C code in that case. Also that one, also for PowerPC stuff and stuff like that, it's not the case. So have a critical look on all the CVEs that are reported here, and then check if that CVE can have influence on your execution of your application directly. So most CVEs here don't have a direct impact on our real Java application, but there might also be newer CVEs that directly have some problems with our application. So Trivy is really easy to install. Just download the binary and then execute the binary against your image. And as I've already told that you can just integrate Trivy easily in Harbor registry, for example. To make it a bit more secure now, you can build a rootless container. What I've changed here now is that I added the user here and using that user with that user ID. So now if I would run that command here with the rootless Docker image, before I have to stop the old one. Otherwise, I would have problems with conflicting ports again. I'm just copy that again here. Then we run the rootless variant now. And again, try to that was the wrong command, just give the right name. It's always better to copy and paste. Now, as you can see, we are not running with root user anymore, so we're just using the application user, so not the root user anymore. And we also have different capabilities also set probably by that thing. Not in that case, so we don't have capabilities set now. We will see how to set them in the Kubernetes part later. So I think I have to hurry up a bit. So I will skip that part with the chip. That mainly does the same as the rootless container, but just using a chip plugin, which makes much more smaller images and also takes out the shell to the container. We will now skip that part and go on to the next part, to the next stage to go into Kubernetes security. But a small summary of container security 101. So really important is that you learn Linux security basics. So you have to understand how containers work, that they use Linux namespaces, use Linux capabilities, use what is called C groups to restrict resource consumption. You should Load images from trusted registries only. So Docker Hub is not a trusted registry, as I can tell. There are lots of images that have malware inside that are put there by intention to be used. Always scan images for vulnerabilities in your CI/CD pipeline, especially. Say no to root for your containers. Do not hardcode secrets into container image. Always use the Docker concepts of putting secrets into your container image on the command line. Limit the resources, memory, CPU-wise, process-wise, and also, as advice, also add the security modules like ccomp, AppArmor, SE Linux above. So Docker has also some default sets configured for you already for Linux security modules, which is also a good fit between security and usability already. So next stage would Kubernetes security. And always my first slide before diving into security with Kubernetes is the question, do you really need the complexity of Kubernetes? I've seen lots of projects that just use Kubernetes because everybody now uses Kubernetes. But that is not a reasonable choice. If you are an architect, I would always ask the architect, why do you need Kubernetes? And if I get the answer, oh, I want to try out Kubernetes, it's the newest technical thing to do, the whole world is using Kubernetes, so that is not a good answer. You should always have a business-like reason for using Kubernetes. Like you have plenty of applications you have to orchestrate. If you just want to put one application as a container in a productive environment, Kubernetes would be a much too complex environment for you. So it is a complex beast, as I can tell. And lots of developers don't understand how Kubernetes really works. So my recommendation is always to also check alternatives for Kubernetes. Very easy one is, for example, AWS Fargate. You just push your container into the Fargate service and you don't have to care anymore how to configure that. In that case, how to configure the infrastructure. So all that managing of a Kubernetes thing is not your case anymore. You just have to deal with your one application, make that application secure. Don't use root as user in a Docker file, and then just push that container into Fargate. So AWS deals about the rest. Also, you could use Google Cloud Run, which offers the same. You could still use Docker Swarm, which is not that prominent anymore because of Kubernetes. Another alternative would be HashiCorp Nomad. And then if you come to the point, yes, you really need a Kubernetes cluster, then the second advice would be never run your own production cluster yourself on premise or stuff like that. Always try to use a managed Kubernetes cluster. There are really good clusters available by Azure, by AWS, by Google, like the AKS, the EKS, the GKS. So we will have a look shortly into GKS, the Google Cloud Kubernetes cluster. Always use a managed one. So it is quite easy to spin up a production cluster at once at first stage, but it's really really difficult to constantly patch and manage that Kubernetes cluster in a secure way. So that's a really hard effort to take. So these are a really short Kubernetes basics overflow. So on the right side, you have your Docker containers. You put them what is called inside a pod. And a pod is the smallest unit running on Kubernetes, as you can tell. So you can put many Docker containers in one pod, but so the usual recommendation is that you have a one-to-one association between a pod and a container. You just only use plenty containers if they really have a shortcut communication, which would not be possible over different pods via usual network connection. So if you have a requirement that these two containers could not communicate over normal network connections, then put these inside one pod. But in 90% of all cases, just put one container in one pod. And then the main thing about Kubernetes, why all people use Kubernetes, is the scaling part. So Kubernetes deals about all your applications. So you tell, I always need 2 instances of twice to Bitcoin mining your cluster, then at least you should get notice of that. So the last part I will go through quickly is the Kubernetes secrets part. So how to deal with all credential secrets on Kubernetes. So it's not only a problem of Kubernetes, but also how to do that in your development environments. So a lot of people also put secrets in clear text in your Git repository, which is also a bad thing. So the good news is that you could also use Google key management systems for both parts, for Git repositories and also for Kubernetes to solve the problem. So these key management systems then do the encryption, decryption. So all secrets only are inside here. And you don't store them in your Git repository anymore in clear text. So Kubernetes secrets look like this. That's a special YAML file. As you see here, these are base64 encoded, so not encrypted. And by default, if you don't configure a Kubernetes cluster in a correct way, they are also written only in base64 format in the etcd database by default. We have seen that. Pay attention to Spring Boot Actuator. And this is what cloud providers do now for securing secrets in the etcd database. They do secrets encryption at rest, so that the database itself is encrypted on the file system. So if one steals the etcd database, cannot physically access the secrets anymore because they're encrypted. And what is called application layer secrets encryption, that is also added by Google, for example. You just switch that on by some checkbox, and then it's also in transit encryption in place. This is the mechanism, how it works. So it uses 2 levels of encryption keys, a key encryption key, which lies in the key management system, and the encryption key that lies in Kubernetes to even make it more secure. Always use a key management system like Azure Key Vault, Google Cloud, AWS KMS, HashiCorp Vault, and stuff like that. So HashiCorp Vault, I've taken that picture from HashiCorp, also offers a new feature called Kubernetes Sidecar Injector, where you have to do some build stuffs here to define roles, use the Kubernetes public CI cert, then configure your secrets, and then that injector is put in as a sidecar into your pod, and it deals with getting secrets from Vault, authenticating to Vault for getting secrets, and then it deals with the whole secrets communication between Vault and your pod afterwards, and you don't have to care anymore about where to put your secrets. These are all in Vault, and Vault takes care with the sidecar to manage all these things. So there's a really good tutorial with that link beneath there. And what about secrets in Git? You can also use KMS systems like Vault, and also use things like Helm secrets and stuff like that. So best practice here is always encrypt secret data at rest and in transit, and only base64 encoded by default. So always take that in account. And also don't mount secrets, do mount secrets instead of doing environment mapping. Environments are always getting through logs and caches and stuff like that. So this is the summary. Kubernetes complex, check alternatives, follow application security 101, follow container Kubernetes security 101, ensure your secrets are encrypted, never store secrets in source control, and check out all the demos we did not have the time for today. So there are really good books to be recommended. So if you want to know how Linux really works, there's a 3rd edition coming, I think, March next year on that book. Then if you want to harden your Linux security and understand Linux security, there's a Mastering Linux Security book on that topic. And when it comes to container security, there's a really good book by Liz Rice that was created this year. by O'Reilly. I can strongly recommend that container security book. It goes much more deeper into detail than I had the possibility today. I'm finished.
Thank you very much. So you can continue communicate with your audience in the Q&A Zoom room and also answer all the questions here. And I want to say thank you for you. Thank you very much. And bye-bye. See you next Devoxx. I hope so.
Yeah, thank you.